All right, today we are pulling back the curtain on a process that shapes, well, pretty much everything. From the news you read to major scientific breakthroughs, we're diving into the secrets of data collection. So let's start with a really big question. How do we take something kind of fuzzy, like an opinion or a feeling, and turn it into a solid, verifiable fact? Something we can actually work with and build on. Well, the answer really boils down to one fundamental idea: measurement. The way we observe and record things is the bridge that takes us from having a simple hunch to drawing a real conclusion. So let's get into it. To really get our heads around this, we have to understand that measurement is absolutely at the heart of all research. It's the framework that gives our observations some structure and lets us find real, accurate answers. So, what do we actually mean by measurement? Well, officially, it's the process of observing and recording the observations that are collected as part of a research effort. In plain English, it's just how we systematically capture information, turning abstract concepts into something concrete we can describe and analyze. But here's the thing. Not all data is the same, not by a long shot. To really know what we're working with, researchers talk about different levels of measurement. And this is a huge deal because the level tells us how precise our data is and what kind of analysis we can actually do with it. The best way to think about this is to picture a ladder. With each step we climb, our data gets more detailed, more precise, and frankly, more powerful. Okay, so let's start climbing. The first step we're talking about today is the ordinal level. This is all about ranking. Think about a coffee shop star rating. We know that 3 stars is better than 2, and 2 is better than 1. There's a definite order there. But here's the catch. Is the jump in quality from a 1-star to a 2-star coffee the exact same as the jump from a 4-star to a 5-star? Probably not, right? And that's the key to ordinal data. We know the order, but we don't know the exact distance between the steps. Take one more step up the ladder and we get to the interval level. Now, not only do we have an order, but the distance between each value is equal and meaningful. The perfect example is temperature in Celsius. The difference between 10 and 20 degrees is the exact same amount of heat as the difference between 20 and 30 degrees. But, and this is crucial, there's no true zero. 0 degrees Celsius doesn't mean the absence of all heat, it's just another point on the scale. And that brings us to the very top of our ladder, the ratio level. This is the most precise level of them all. It has everything the interval level has: order, equal intervals, but it also has a true absolute zero. An absolute zero means the complete absence of the thing you're measuring. Think about the price of your coffee. $0 means it's free. There is literally no cost. That true zero is what lets us make comparisons, like saying a $4 coffee is twice as expensive as a $2 coffee. Okay, so let's do a quick recap. Ordinal data just gives us a ranked order. Interval data adds equal spacing between the values, and ratio data goes all the way by including a true, meaningful zero. Now, this might seem a little academic, but it really matters. The level of your data determines the kind of math you can do, and ultimately the kinds of conclusions you can confidently draw. So, in a perfect world, our measurements would always be flawless. But, we don't live in a perfect world. Things go wrong. And these little measurement errors are like cracks in the foundation of our research. If we ignore them, the whole thing could come crashing down. Research usually points to 2 main culprits. First, you've got systematic error. I want you to picture an archer who consistently misses the bullseye, and all their arrows land in the top left of the target. It's a consistent directional bias. Then there's random error. With this, the arrows are just scattered all over the target. It's unpredictable, it's messy, and it's caused by pure chance. So what does this actually look like in practice? Well, a classic systematic error is something called social desirability bias. That's when people give answers they think sound good or are socially acceptable instead of what they truly believe. It pulls all the data in one specific direction. Random errors, on the other hand, are just little hiccups. A person gets tired and misreads a survey question, or a piece of equipment glitches for a second. They happen by chance, and hopefully they cancel each other out over time. So, collecting your own data can be pretty tricky, right? What if you didn't have to? What if the data you needed was already out there, just waiting for you? Well, a lot of the time, that's exactly the case. And there are some huge advantages to this approach. First, it's unobtrusive. You're not interacting with people, so you're not influencing their behavior. It's also incredibly practical. It can save you a ton of time and money. And because the data is already out there, it can sometimes be easier to cross-check and confirm that it's actually accurate. Now, when you're using existing data, you have to know how far you are from the original event. Think of it like a story being passed down. Primary data is the original source, like a diary entry or an interview transcript. Secondary data is someone else's analysis of that source, like a book about the diary. And tertiary data is even one step further removed, like a Wikipedia article that summarizes that book. The further away you get, the more careful you have to be. Which brings us to the absolute million-dollar question. You found some existing data, but how do you know if you can actually trust it? Well, you've got to check for two things: authenticity and credibility. First up, you have to play detective with this source. Who or what is giving you this information? You have to ask yourself, how close were they to the actual event? Did they have a personal stake in how the story was told? Was there any pressure on them to report it in a certain way? This is all about vetting your witness. Next, you need to put the data itself under the microscope. Does the information seem slanted or biased? Can you back it up with other independent sources? And this one's a biggie. Why was this information recorded in the first place? Was it to inform, to persuade, to sell something? Understanding the original purpose can tell you a whole lot. You have to analyze both the messenger and the message. And this really hammers the point home, as the source material says, because secondary data are always someone else's interpretation of primary data. Secondary data must be carefully cross-checked for accuracy. Every time information changes hands, it gets interpreted. So cross-checking isn't just a good idea, it's absolutely essential. So we've gone on this whole journey, from the basics of measurement all the way to questioning the data we see every day, which really leaves us with one final thought for you. The next time you see a statistic, a poll, or a research study, what's the first thing you're going to look for? Will it be how they measured things, the potential for sneaky errors, or maybe the credibility of the source itself? The cool thing is, now you have the tools to find out.